Welcome to GD Gyan. Don't forget to subscribe and click on the bell button.
Hello everyone, welcome to GD Gyan. Today we are going to discuss about data center. I have done couple of video over the AWS, but later I understood that we need one session at least on the to understand how the data center actually is. So I thought to come up with a 101. Welcome me Ganadeep Das here for today's author. Let's go to the agenda. We wanted to know how the data center came, how this entire topology or how this entire infrastructure came in, what is the data center, how it looks like, and why we need even the data center, aspect of data center, what are the different aspect or scope of different data center, types of data center, what are the different types of data center available in the market, data center pricing and the model, and at the end data center migration. Though we are not going to discuss in detail, but just wanted to have a glimpse if we wanted to migrate from our home based model to a data center based model, how that should happen. Welcome, let's get into the real picture now. How data center came. Let's understand what was the first generation computer. You guys remember Koi Mil Gaya, right? So I don't want it to confuse with the tagline. Let's confuse this generation kids by showing this picture. Neither I have used this computer. So there used to be a computer. It's used for compute devices like who belong to computer science, who have worked on the automata. They know the Turing machine, which is called the first computer ever. So this is the first computer that ever came, and slowly it evolved, right, with the time. So the functionality, the structure has been evolved, and with that data storage came in. So the first data storage was floppy disk. I have used that. I had couple of them as of now. 1.4 MB was the storage, and there was few floppy with little bit higher storage, 1.4 MB. We used to copy data using this floppy disk from one computer to another computer. We have done in our schooling, in our college days as well. So once this storage came, the data used to be transformed into small scale because the data even developed into a small scale. The dependency with the computer was not that high. Eventually, when it grown up and when the computer started connecting to each other, to printer, to multiple devices at the same time, it was a need to have a single consolidated space where all the device can talk for that storage. Then the interconnectivity or the networking came, which broadly categorized as a LAN and WAN at some point of time. When all this thing came, we need to have a structure or a place where we can save data. So if we can assume that, okay, I have three devices, one printer, one laptop, one mobile, all connected to a single storage, single compute unit, and I'm getting the data from that place and connecting to that place, updating that place, that is what is called my data center. So if we have understood, if I have a single computer with single CPU, memory, keyboard and everything, that itself a data center model, but it is like a desktop, that's what we are calling. When it goes into larger scale, multiple devices and connected to a single compute unit which has single storage or multiple storage, that becomes a data center. So largely when this become into a bigger shape, so there used to be a unit, a large hall where lot of compute unit, lot of storage unit, and people across this area are connected to that hall. That hall provides you the ability to connect to storage and the compute unit, and to understand your and understand and perform your actual need. That becomes your data center. Finally, the data center, which is physical data center, like for example, I am a company, my company name is gdgyan.com. I am basically located in USA, and I have built USA, suppose in Atlanta. So I have built one data center in Atlanta near to my user base. So all the user who are accessing my website, which is a printing website, they can upload their photo and I used to print them, right? So they used to upload it to the my website, which actually storing them into my data center, which is in Atlanta. And eventually I print it out, I ship it to them, and they can track through my website. So all the operation happens in my data center, which is a physical data center. I own it for my company gdgyan.com. But the people who are from India, Australia, when they tried to access the same data center in Atlanta, they didn't find it very easy to access that. That the time cloud concept came, where you get your data center, you get multiple feature on the scalability, on the high availability, on improving performance, reducing the latency. That time the cloud thing came, which we have it here. But today we are going to discuss about the data center and how it came and how it looks. Let's move to the next slide then. So this is the normal data center for one of the company. I don't want to name it. The data center looks like. So it is located in a place. It's a large hall kind of a thing with multiple unit, multiple power backup, cooling facility, security guard, clear zone, which means there is an area which where people won't be able to enter. Even if it is my company, if I'm not allowed as per the data center policy, I won't be able to enter into the data center. It's as strict as that. You have seen all the movies, right? Where people don't get access to their data center. It's something like that to protect your policy. Inside that, they have this kind of a racks. You can assume it's as an almirah and or shelf where your servers, your storage space are being kept, which is connected over the cable, right? So on the floor, there are different technology that I'll mention on the go, but it looks like this on one rack, and multiple rack creates one row, multiple rows fills the entire hall, and that's what your data center is. So if we have understood the data center, it's a large hall with multiple servers, multiple storage unit. They are internally connected. People across the globe can access that data, can save their data into that place, and can get access to that. Company also can own that. But why we need this data center? The reason is that if I wanted to create my own data center for gdgyan.com in my home, I can do that. But I had to ensure that I'm having proper safety measure. People from outside cannot access it, cannot steal the data. It is power backup, fully connected. Even though electricity goes off due to any of the natural calamity like Amphan or something happened recently in India, it is protected for that. It is protected about any environmental issue. It is protected even after any political issue. Even the electricity goes off, I have the power backup. So all this thing, if you sum up, security, backup, cooling system uptime, you have to ensure that all your systems are running flawlessly. Even though one of your server goes down, you have a backup where you can quickly switch. So high availability, fault tolerance, scalability, all those things, if you wanted to ensure, it will cost you huge to maintain the same infrastructure. So the concept came data center, where it is kept into some place, all those infrastructure related costs being consolidated and distributed, right? So which gives you better model. You can set up your data center in a place where this kind of a situation like natural calamity kind of a situation could be lesser. So based upon that, you can configure it. So you understood the data center concept now. So normally your data center look like this. So we have talked about this rack, so which is one of this shelf. After this, multiple almirah kind of a cell which has multiple racks, and it is the aisle or the lobby where you can pass, the engineer can go. So there are two types of data center model. One is your raised floor, where your entire data center on a floor which is raised from actual floor, and they pass the cold air or the cool air inside this rack and take the hot air from this raised floor. So when you pass through this corridor, this aisle, whatever you call, you feel it's okay, you don't feel it warm. But there are some old data center where they don't have this raised floor. So what happens when you cool your compute unit, the hot air comes to this passage. So when you walks here, you might feel that okay, it is bit warm, it's not as cold, but it's due to the way that you have been configured. So you have to take care, you have to pass cooled or cold air inside the rack so your system runs properly. You have to take out the hot air, so you have to have that kind of technology or method into your data center. You have to control the humid and other environmental parameter as well. Let's look into this thing. So in a normal data center which we have talked now, apart from the cooling method, we have a NOC room, network operation control, or a command center, which actually a separate room who monitor into large screen, 7-8 screen, and all the different software been running, which monitor each of the system, their uptime, their downtime. It pops up whenever something goes wrong. An engineer can who's actually allowed to come here. So in some of the data center, the NOC or the command center people are not allowed even to come inside the data center, actual data center. So there are separate engineer who come here, who fix that and goes out. You have a power backup center, you have multiple power backup method. You can see standby. Apart from the normal electricity power, you have to ensure that even though the electricity goes off, you have a power backup here running uptime and giving the uptime. For that, security means not only the security which ensure that okay, your unit is safely running, you have to have a physical security also. For example, you're running a data center, your competitor may try to come inside and steal some data or understand some part of it. They can steal some of the customers data information that you have to protect, right? So this is how your data center look like. And finally, one more picture. I just wanted to show the hot corridor, the cold corridor, which is inside the racks, your IT room, how the data center hall, the support space, and all those things. So each of this rack that we have discussed so far. Now discuss about data center aspects. So let's look into this slide, so which will give us a full overview. We discuss about that. So if we are going to build a data center, or if we are going to understand a data center, these are the aspect that we should look into it. Power and the cooling. So you need to have a proper power backup and proper cooling method so that your systems are running properly. So end goal is that uptime, our systems uptime should be high. Security, you should have enough security being placed for your data center, which means the physical security that has to have a proper way so that anybody or anyone cannot come inside your data center. There has to be a clear zone, which more like a border, I mean, like a line of border where we should not cross, something like that, right? So it should be also having a clear zone where people without access should not even enter that area. Even they are entering, that should be highly alarming, and that should be alerted the uh, local cops and the authorities. Infrastructure, you need to have a high available fault tolerance infrastructure, which means the in your data center you have to have the fallback. So if you have two servers, so one and another server should be fallback to each other. So one is primary cluster, second one is the secondary one, or the fault tolerance in the sense same data being replicated to multiple devices so that if anything goes off, other one goes up. So that comes a bigger picture that we already discussed in our cloud program, which you can find into AWS my playlist. However, for now, to understand high availability means your data, you ensure that being available at any point of time, which means multiple servers are running to give it a fault tolerance. And scalable means you can upgrade your infrastructure based upon your need. So if you feel that okay, at some point of time multiple users are going to access your system, so you are increasing the hardware capability or decreasing your hardware capability. So that is your scalability. And at the same time, read replica ensure that multiple copies of the same read also ensure that how you are going to get even though some data being lost. So for that we need to understand the RAID 0, 1, 5 and 1, 0, but that will cover at some point of time. But understand high availability, fault tolerance, read replica, and these infrastructures are equipment, all the equipment which considers your fire extinguisher, fire, your cooling equipment, your raised floor equipment, your IT equipment that you need to have in the place. Maintenance, staff and operation. So staff for maintaining the property, staff for monitoring the command center, the NOC, all the operation that will ensure your systems are being done, your all the software and hardware which also ensure that okay, you have the right infrastructure to monitor whatever, even there is a power failure in one of the one of the units, some of the PDUs are not working to the any of the equipment, some of the storage devices are offline, everything being alerted into that command center and immediately being noticed. So, and apart from that attack, so it could be online or offline attack, which means any of the malware, any of the phishing method, or any of the way they are attacking your data. So we need to ensure that all these data center aspects which makes the data center so powerful. Just an example, in this world, right, maybe 15-20% are data. So this data center what I'm talking is a physical data center. However, I mentioned there is a cloud data center which is AWS, Amazon, Google Cloud, or IBM or Alibaba, right? There are lot of providers who provide cloud data centers. So this security, this scalability, all those things, right, they need to ensure in the data center. And if you think about in current world, most of the 80, I mean 70 to 80% companies are still holding the physical data center. Though we talk a lot about the clouds and all, but maybe only 15 to 20 or maybe 25% of the data now converted into hybrid cloud or public cloud or any of the cloud provider. So you understand that people still relying on their physical data center because they can own the safety measures, infrastructure, their equipments. They still, this world is not turned into the page where physical data center completely gone and cloud data center is coming up. So though we are talking a lot about clouds, all the cloud technology, but you understand only 20 to 25% data now converted into cloud. So you assume on a different note, if everything gets converted into cloud, what would be the job opportunity in the cloud? Or if we learn how to handle physical data center, we are still counting that 75% of the job that we can hit now. Let's go to the next slide, which is data center components. So understand this thing that if you buy a desktop laptop, you need to have this thing. You need to have a storage, you need to have a CPU compute unit, you need to have networking unit. I mean, even though you have one computer, maybe you are connecting with a printer, you're connecting with your mobile, so that kind of a networking. You need to have a power cooling, so you have a AC room where you're keeping your computer, right? And hands and feet support means for your computer you need somebody in case your storage goes down, your screen shows a blue screen, your RAM is not properly installed, your printer is not working, software issue. So for that also you need hands and feet support, which we often go for local technicians. So when it comes for the data center, it goes into thousands or I mean lakhs of multiplications, right? It goes in terms of such a big number that we need to have a huge storage. So storage, mainly the block based storage or the file based storage, we discuss in our AWS storage topic. But block based storage is the storage where you can install operating system database. Object based storage, anything you can configure. Even though you are installing your operating system, you can copy that as a file in object based storage, but you cannot install that in object based storage. File based is a NAS. It's a bit old technology, but it's a hierarchical storage model. So file is NAS, block is SAN, and object is definitely is the object kind of a thing you can store. Compute unit, you have a shared computer, so which means one compute unit shared between multiple users. You have a dedicated computer compute unit, and you have a virtual compute, so which also recently came in with the lot of provider, right? So VMware, Citrix, Zen Computers, or the VMware ESXi VMs, right? So all those things came in. We'll discuss that. Networking, how this all the storage compute unit are connected to each other, connected to external world. Power cooling, we discussed that. Hands and feet support is my NOC or command center who are actually managing the data center. So again, all this service that we have, we need to ensure they are fault tolerant and highly available, so that our customer get a confidence that they should be using this data center. So now let's understand about this little bit about the virtual compute unit. So you have an infrastructure. So for any computer or compute unit, what you need a hardware, right? So you have a hardware. Now you have an operating system, right, on top of the hardware, which is accessing the hardware, which is reading and writing to the hardware and giving the instruction to them. And on top of that, if you have a hypervisor who actually managing this entire span of hardware and operating system. So this VMware concept of hypervisor, which actually made this one single hardware or one single operating system into multiple compute unit, that is called your virtual unit. So multiple VMs are now hosted on top of hypervisor, which is accessing a one OS and hardware. So basically you are getting a virtual kind of a computer. So we'll discuss more on detail, but for now you understand the storage and the basic of the compute unit. But you understand that, right? So whatever types of compute you're going to access, whether VM or dedicated physical boxes or dedicated or shared physical boxes, so based upon your choice, suppose you are a government authority, you don't want your compute unit to be shared with anybody else, so you need a dedicated one. If you do not have that protocol that okay, I can share my compute unit, it doesn't matter unless it's giving me the service they are agreed to, you can go for shared. So understand, in all the cases it will ensure your security. Even though you're using a shared compute unit, that doesn't mean that it would be your anybody else accessing the same data center, paying the same money along with you, can access each other data. That will not. But again, for safety, the government or the larger financial unit, they prefer to have a dedicated. And as I mentioned in my previous slide, 80% of the organization or 70 to 80% of the organization still hosting data into their own physical data center. Understand the types of data center that we have. So we have this four basic type. Enterprise data center. So I have my gdgyan.com company. I created my own data center based upon my purpose. I felt my users are in India and USA, so I created two data center. One is near to India and another is near to USA, because so that the people accessing from India to USA should not have the latency. In case I do not have that money, definitely I go for the cloud, because there I have option to choose, shift, swap, repurpose, restructure my data center based upon my need to any of the region, right? So that's why the cloud computing comes, that we discuss into a cloud structure. But let's understand the next type of data center, managed data center. So suppose I'm a company who actually have a data center, and I give my data center lease to many of the companies. So there are people, right? There are abc.com, cdf.com, xyz.com. These are the company, they need a data center, but they don't wanted to invest that upfront infrastructure cost. So they came to me and they asked me that if I can give him the data center by lease. So they came me, I allocated them space, and they got this thing. Definitely security and components, monitoring, uptime ensurement, safety, everything owned by this company, which is me. And they only takes the data center advantage on their user access through that data center. So they just need to migrate their on-prem or their local application to my data center, and they access it. Co-location data center, where I have the infrastructure, cooling method, power backup, security, my stuffs and all. I have the space, but I'm giving the space to company. You guys come here and configure your own data center. You install your own types of compute unit, own storage unit in the racks. You manage it. So it is called co-location data center. In the same space, multiple company can have their own thing. They can have their own engineers to manage those things, and it would be by them. I'm only giving them the infrastructure or the place or the other stuffs that I needed. And definitely the cloud data center. So cloud data center biggest advantage is that if you feel that your data center located into in particular region, particular geographical region, and people across the world may be facing some latency, in cloud that is not, infrastructure cost will go down significantly. If I'm owning a data center, that cost will go significantly, and that has been proven. Your 15 to 20% cost will go down. You do not have any upfront investment for accessing this data center. Even though you are accessing the highest level of compute unit, you are paying just on hourly basis or second basis, based upon which model you go, either it's AWS, Azure, GCP, IBM Cloud, or Alibaba, right? So based upon that, they all have different method, where AWS is the prominent one, Azure is the coming up, and GCP could be a one in future, making a big difference to any one of this cloud provider. So hope we understood the types of data center. Let's move next. So what are the data center tiers or tiers, right? So which types of data center, if I'm using a physical data center, not the cloud one, what are the different tiers that I should be accessing? So they have this four tier, 1, 2, 3, 4. So tier 1 ensures the lowest level of node redundancy. Your availability also less, you can see 99.671. Tier 2, which includes your tier 1 capability and increase the redundancy somehow. Downtime also very less, compared to tier 1, and it improves. So like this way, you go to tier 3, you go to tier 4. Tier 4 gives you the all the facility in tier 1, 2, 3, and includes 4. It has the power backup, it has the cooling backup, and availability also very high, 25 minutes. Just on another note, in cloud AWS, right? So I have heard that in till the time they have launched in 10 years, might be the entire 10-15 years, the downtime was 25 minutes or 1 hour, something like that. So compared to physical data center, cloud data center are preferred, but still companies are sticking to physical data center. Why? I don't know. Maybe the mindset that needs to be changed. How people still like the work into waterfall model, not prefer to go to agile. Even though they work in agile, they work like waterfall only. So that mindset needs to change. The one we started with the DevOps, Smart Ops, then BizOps, right? All those things came up. So I hope that cloud model also go and pick up very easily, but definitely the cost is lower and efficiency is little higher. So even though I go for the highest level of data center tier 4, it still doesn't give me 100% of availability. It gives me 25 minutes of downtime. Okay, so that is the end of this slide, and just stay here for a few seconds to understand the data center migration. You need to have a airflow management, turn heat. You need to have a proper heat or cooling method. You need to have the proper floor step advantage. You need to have a proper zone so that the existing data center benefit from one zone to other zone. You can separate it out, right? And again, if you wanted to migrate your data center, consulting, architecting, your DC needs to be built out. All those factor or aspect that we discussed. Infrastructure needs to be consolidated, and infrastructure needs to be configured with the virtualization. Your DC migration, the next step, and then the DR configuration and the DR drill and testing. And even you have a data center, you need to run the mock drill. So thank you all for staying connected. Hope we'll meet soon with the next topic. If I have another topic of the data center, how the hardware replacement being done from the data center in case of any of the hardware device failure, I'll come up with that. I'm planning to prepare one such video as well. Thank you all. Stay tuned. Bye.
Please like, subscribe, share. Thanks for watching.